find the particular solution, solve the differential equation, like verbiage like that, and it doesn't say show separation of variables, you still got to show separation of variables. That makes sense? So I'm like really trying to give you a hint, like you got to do this. But even if they don't say that, that's like an expected logical step as far as kind of the algorithm, the pattern that we use to solve these separable differential equations. So with that in mind, how many of you did this on that separate the variables step? Anybody do it like that?
Can you bring the 6 with?
Did you guys take the 6 with? Okay, you can definitely do that. And how many of you did bring the 6 with? Raise your hand. That's really typical to see that. So I will go ahead and do it your way, but let me just say that I would prefer to not do it that way, and let me explain why. Knowing that in the end I'm going to get y equals blah, 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 whatever. I know I'm going to have to get the y by itself. In my way of thinking, the less I bring over with the y, the better. I'd like to bring as little as possible over. This 6 is not going to make that much of a difference, really. But the less I bring over, the better, because that means less for me to do later. And let's be honest, right now it's just a 6, but it could mess you up, right? It could. So let's go ahead and do it the way you guys described. Let's bring the 6 over here. Once you've separated the variables, you've opened the door for you to show what you know, right? So this is that key step that allows you to move forward. What comes next if you do separate your variables? That's right. So we're going to do an antiderivative of both sides. So over here, maybe I show some steps, right? Maybe I go 1/6 integral y to the negative 2 dy, something like that. I haven't done anything yet as far as antiderivatives go, but I've done a little bit of preliminary work. Now I'll do an antiderivative. So on the left side, it would be negative 1/6 y to the negative 1 equals 1/3 x cubed minus 3x plus c. So what do you think about that?
Yeah.
That 6 mess anybody up? I've seen it happen. No? Okay, good. I definitely don't want it to mess you up. I've just seen people where they're like, oh my gosh, if only I had left that over there, I wouldn't have done the thing I did, and whatever. Okay, so we're good? So now how on earth do we solve for y? Because that's always going to be your last step, because we've got to make sure this thing's a function. Any suggestions on what would you guys do first if you were going to try to get the y all by itself? I'd say even before that. I'd like to get rid of the 1/6, right? So let's multiply that back over. So I'm going to go ahead and... Negative 6. Yep, exactly. Okay, so I'm going to clear out that fraction, that negative fraction, multiply by negative 6. So that's going to give me y to the negative 1 equals negative 2x to the third plus 18x. And technically it's minus 6c, right? But we know that minus 6c is really just what? Some other plus c, right? So if you put minus 6c, I wouldn't have any problems with that. I'd kind of prefer you did that. Acknowledging informally that the c is a different c than the previous one. In fact, if you wanted to put a k instead of a c, I'd be okay with that also. But anyways. So let's take the other suggestion that was given out there, that y to the negative 1 is really 1 over y. And this is sometimes where we get ourselves into a little bit of trouble. How on earth do we solve that? So I totally agree with you, Santi, and that's a nice algorithm. And maybe I'll do a little simpler algorithm. Are you guys okay with this? Does that make sense? So you could cross multiply. So if you did, you would get y times negative 2x cubed plus 18x plus c is equal to what? 1. And then if that were the case, your final step would be division. And then I want to come back to what Santi's point was a second ago. He brought up a good point. But sometimes people maybe don't quite see why that is. Did you notice how essentially this and this changed location? And that is a valid little algorithm. If you've got a oh gosh, the word is escaping me. A proportion. If you got a proportion, you can like exchange diagonally, and you're good. Okay, so that's a general solution to a differential equation. And I gave you guys some time to kind of run with that, and I came back, was that hard, medium, difficult, easy? Where did that fall on your spectrum? Do you have any questions? I hope that went well, but maybe there was some detail that, you know, you're looking up at my work, and you're looking at your work, and you're thinking, I don't know, something doesn't make sense. And if it all makes sense, obviously, we're excited about that, but mistakes are welcome. Questions are welcome. Doubts.
Can we do it with just the y squared?
Can you do it with just the... Oh, like the different version? Sure. Okay, so are you guys all okay with that? Because I'm going to erase it all here in a second. Okay. So what if we did it that other way that I suggested? How would that turn out? A little different, but in the end we should get the same answer. So I would write this as dy over y squared is equal to 6 times x cubed minus 3 dx. So again, this is an opportunity to drive the point home again. Make sure you separate the variables correctly. Don't leave the dx off. Be super careful. It's not like it's that difficult, but it's difficult enough where if you're like mentally in neutral, you could mess it up. So take your time, do it right. All right, so then we do an antiderivative of both sides. So over here I get negative y to the negative 1 equals 6 times 1/3 x cubed minus 3x plus c. The 6 is already over there. I could have just left it in there, I suppose.
Could you put it in before you do it?
Sure, I could have distributed it. Yep, maybe that would have been a better move. And then you can see we're headed for the exact same place, right?
Yeah.
And so you can look at that 6 and say, golly, is it really that big of a deal? Well, maybe, maybe not. But I would prefer simply to leave as much stuff over there with the x's as I can, knowing that in the end I'm going to be solving for y. Why not make it easier to finish than tougher to finish? So Bailey, is that good enough?
Yeah.
Because you can see we're in the same spot there. Okay. Okay. Any questions, concerns, comments? Okay. So then let's move forward. Numbers 1 and 2 were both... Oh, I'm sorry. Go ahead.
When you moved the y over and got like dy over y.
dy over y squared?
Y squared.
Yep.
And then that became like, why does that become negative?
Oh, sure. So I did skip a step in there. I would rewrite this as this. And then when you do your antiderivative with a power rule,
Oh, you add one.
you add one and then
Okay.
divide by the
Yeah.
new exponent. Yeah, so it'd be y to the negative 2 plus 1 over negative 2 plus 1.
Yeah.
And that's where your negative comes from. Yep, good question. Yeah. You got to build this in your head, right? And so that's a good question of like, wait a minute, that didn't make sense. So, yeah. Anybody else? Okay, so then numbers 1 and 2 are both general solutions. What is the one symbol that characterizes a general solution? Yeah. If you see a plus c in there, that means that you got a general solution. And of course, if given a little more information, we can actually find the c, which would end up giving us a particular solution, is the term there. And so this one here is not too different from ones that you have done in the past. And so I'm hoping that you have a good chance to navigate through number 3 here. So kind of like we started off the morning with, let's give this one a shot and see how it all goes. I'm here to help if you have anything you want to talk about. So try number 3, please. I certainly understand why you did it this way. I'm going to show you a way that's a little bit different, and I want to explain a little bit about why, and I also want to explain how, like, points and such, I want to kind of remind you of how, like, you know, we always want to know, like, how am I going to be assessed? How am I going to be able to show what I know? So I want to show you those important steps. Okay, so I mean, even reading the instructions, it says you got to show separation of variables. So hopefully that's obvious enough. We got to do that. So for this one, you would write y dy equals 6x dx. And let's kind of keep a tab on points right here. If you wrote that down, you're at +1. You just earned a whole point. Yay. So lesson to be learned there. God forbid, you're taking some test and there's only like 30 seconds left and you're trying to do a question like this. At least write that. You probably just scored a point, right? So consider. Hopefully, like I said, hopefully you don't find yourself in that situation, but if you do, instead of just like panicking and not doing anything, at least do that. Okay, step number 2, antiderivatives. So 1/2 y squared equals 3x squared plus c. So at this stage, you have earned either 1 or 2 points, and that usually depends on how tough the antiderivatives were. In this case, I'd say that the antiderivatives were both fairly straightforward because they were both power rules, and so I'd say probably +1 right there. So the next point to be earned on a question like this is kind of a combo, and I'll show you here in a second. And this is where you and I kind of diverged in our paths. What I'm going to do right now, and I will be really consistent, but you don't have to do it this way. I'll be very consistent, and I have my reasons. I'm going to plug my initial condition in right now. The truth is, I have found, like that right there, that second line,
Oh, I really thought about
that is my general solution. It's just not solved for y yet, right? So there is nothing stopping me from saying, hey, let's just plug in the initial condition right now. And I do like this for a couple of reasons. So let me write this out, and then I'll explain one of my reasons. So this basically means when x is 2, y is -2. So -2 goes here, and x is 2 goes there. So I've just plugged in my initial condition. Here is why I like to do it there, because typically for these, your next point is based on, did you have a plus c, and did you plug the initial condition in correctly? That make sense? And so these questions are usually either worth 4 or 5 points. And as you can see, if that's all I've done here in 3 lines, I've either earned 3 of the 4 points or 4 of the 5 points, all but 1 of the points. So I'm a fan of doing it here simply because I would rather solve with numbers rather than a bunch of extra letters like y's and x's. That make sense? So this is where there could be some interesting things. Check this out. And you feel free to object to any of this if you see fit. Okay, so I'll just do a little evaluation. So over here on the left side, that's 2. Over here, that's 12. So when I solve for c, this is what I get. Potential there for some squawking, right? You might say, wait, I got 20 or -20 or something, right? For c. So this is where we get to talk about, do you remember when you multiply through by something, it's a c still, but it's a different c. But if you, no, listen. If we do it right and we get our timing and our organization correct, we should all end up with the same answer. Check this out. I'll highlight this, I used this step right here to plug in my initial condition, right? So when I find my c, in this case -10, that's the step that I need to plug back into. So check this out.
Oh, so you will get.
I think you'll be pleasantly surprised. So 1/2 y squared equals 3x squared, and I know my c is -10. And now I'm going to solve for y. I'm holding this off till the very end. So I clear that fraction out by multiplying by 2, and do you see it? Y squared equals 6x squared. Hey, we're back to being happy again.
We were so stressed.
Yeah, that's why I said this was going to be interesting. I could see that maybe we'd have some different looking stuff in between, but so do you remember what I said a few minutes ago about timing? When I'm talking about timing, I'm talking about, well, which C exactly are you talking about? And you need to make sure that the C you find is the C that you actually plug back into. Does that make sense? Let me finish this, and maybe I can give you an example of timing, bad timing. Have you noticed I haven't awarded any more points to myself yet? Because I haven't earned any more points yet. I'm about to, though. I need to square root both sides, so y equals plus or minus the square root of 6x squared minus 20. I still haven't earned my last point. Here's why. I said this a couple times, but it's been a little while, so I need to say it again. The solution to a differential equation has to be a function. And the fact that y equals plus this or minus this means that that's not a function. We need to pick either the plus or the minus. Got to pick one or the other, right? Because if I told you that, hey, y equaled, think of it on a graph. If I told you that y equals plus or minus 2, that means for some x value, y equals plus 2 or minus 2. Do you see how that's not a function? Doesn't pass the vertical line test. So I need to pick either the plus or the minus. Any thoughts on which one you think it is and why?
It's the minus.
Why do you think it's negative?
If you plug it back in, the square root's going to be positive, so it has to be.
If you plug
If you
it
plug-
back,
If you plug the 2 back in, the y of 2 back, yeah, then. the square
oh,
root's gonna
okay.
be
So
positive.
if you take this and plug it back in,
Yeah,
that you'd need the minus to make it true.
yes.
Let's check it out.
So that's-
There's a faster way to do this, but let's explore this because I think your point is well taken. So this means y is negative 2 when x is 2. So negative 2 equals plus or minus, so that's 24 minus 20, that's 4. So negative 2 equals plus or minus 2. Do you see why you have to pick the minus? Because negative 2 doesn't equal plus 2, it equals minus 2, negative 2. So you do have to pick the minus. And Santi's point and reasoning is well said. Let me show you a fast way to think about this. If you're ever faced with plus or minus, look at the y values, the y value of your initial condition's sign. So up here, the y value on the initial condition was negative. That means we need to pick negative. So my final answer, my final particular solution would be this.
Oh, it probably can't, it's not a particular solution if it says plus or minus, right? Wouldn't that also make it general?
Well, no, it would still be, that would be particular, except it's not a function. And your solution has to be a function. Right? The plus 5 minus 5 would fail the vertical line test.
Yeah, so it would only, your answer would only have plus or minus in it if it was asking for a general solution.
Yeah, because you wouldn't be able to pick. That's right. Yep, that's right. Okay, so you can see that I've awarded myself the last point because I just finished. So something to think about here as far as, again, being efficient and considering what's valued. Calculus is valued. Bless you. Calculus is valued. Calculus is valued. From there on out, all of this and all of this, what would you say that is? That's algebra. And algebra is valued, for sure, but not nearly as highly as do you get calculus. That make sense? Do you want to see an example of bad timing? I'll show you an example of bad timing. So let's say I did this. So this would be the kind of thing you'd want to avoid. Let's say you did everything that I did over there. You got c equals negative 10, feeling pretty good. And then you come back over here and you think, oh gosh, I need to solve for y. So then I multiply everything through by 2. And I say, hey, y squared equals 6x squared. Well, hey, 2c, that's just some other c. And then I think to myself, oh, okay, I'll just square root both sides. Y equals plus or minus. Oh, look, the initial condition was minus. Why don't I just go negative 6x squared plus c? But you know what? I just found the c earlier, and I know that it's negative 10.
So you have to plug it into where you got it from.
Yeah, you got to plug it into where you got it from. That's what I mean about timing. So this would be wrong. Oops, you can obviously see that that's a different answer, and it's wrong because this c right here is not the same as that c right there. My timing's off. That make sense? Anna said it well. Where you got it from is where you got to plug it back into. Good? All right, if you haven't already looked at number 4, please do. This will be good. Good. So like I said, I feel like maybe there's an additional step or two on the whole separating of variables. Did you guys do this first? dy dx equals 5xy squared.
Yeah.
Don't you have to add that over first? I mean, that's unavoidable. And then, how about this? Dy over y squared equals 5x dx. You guys good with that? How many points have we scored if we did that? I think I only got 1 point. So right now I'm at +1 because I have shown my separation of variables. Now what I'm going to do is I'm going to find my antiderivatives. So do that to both sides. That's going to give me, this is similar to that general that we did earlier. And over here I get this and that. So take a look at what I have, look at what you have. Does it all make sense? How many points did I earn for doing that? Probably one more point, I would say. Again, all I had to do was a couple of power rules. So probably I've got 2 points going there. I don't know what you guys did. I know that it would be this time when I would like to plug in my initial condition. So I'm going to do that here. That's going to give me negative 1 to the negative 1 equals 5/2 times 2 squared plus c. And I would recommend that you guys do it just like I am there. Like, listen, we all know that 2 squared is 4. And we know that that causes almost no cognitive demand on your brain. I get it. But you want to show, hey, I plugged the initial condition in. Look, 2 squared, 1 to the negative 1. So, how's that going to work out points-wise? It's probably a gray area, I would imagine. I would encourage you just to plug it in. And let's do the arithmetic in our head later, like right now. So if you do this, you would say this is negative 1 equals 5/2 times 4 is 20/2, which is 10. So like you folks over there, Young and Eden, you guys, I got negative 11. We were debating about negative 10 or negative 11, right? I got c equals negative 11. Yeah.
Okay, so since the original condition is -2, even though it's squared, does it matter? Could you just put 2 inside the parentheses? Or would you prefer that we do negative?
Oh, goodness gracious. I don't know what my problem is.
Because technically you didn't plug in the.
No, that's not even technically. So I don't know what, I must have got distracted by my own talking. It should have been -2.
Okay.
Yes. Hey, this is a case where I got distracted by whatever. Obviously it's a -2. And so if something doesn't make sense, you say, something doesn't make sense. That's a great question. Thank
If you.
we did that on like a test or a quiz, would dock us points for like putting it as a positive, even though like once it's squared?
The result, of course, is 4 regardless.
Yeah.
I don't know. I don't know if anybody's ever done that. At least nothing jumps out to me. Nothing sticks out to me like there was a time when I had to make that decision. So, I don't know. I'd have to think that one over. All right. So then I'm going to use this now to help me find my final particular solution, be negative y to the negative 1 equals 5/2 x squared minus 11. Clear out the negative. So it'd be y to the negative 1 equals negative 5/2 x squared plus 11. And then we could do that whole flipperoo thing we did last time. And maybe this time we use Santi's idea right away and say that essentially this is over 1. So why couldn't we just exchange the two of them and get y equals 1 over negative 5/2 x squared plus 11. If you wanted to, you could get a common denominator and add and copy dot flop and take this from being a complex fraction to a simple fraction. I don't care. Do what you want, but you could leave it like that.
So if I flipped them before I multiplied the negative over,
That should still work, right? Because then you would have ended up with a negative 1 in the top over 5/2 x squared minus 11.
is that?
That's fine.
Is it okay if the negative is like out front?
That's fine.
Because it's not.
Well, that's totally fine. Yeah, the out front is kind of tough because it's like, is it up there or is it down there or is it like right even with the fraction bar? Because it would all make a difference, right? I tend to I'm going to tend to put it on the top or the bottom, just to make it clear where it actually needs to go. But
that's the same.
that's a valid answer for sure.
Okay.
Yep, totally valid answer. Any other questions on that one? All right, so then we're going to finish with one that should be fun. This should be interesting. Let's take a look at number 5. I want to kind of work this one with you, but I want you guys to supply a lot of the key steps, and we'll get to an important one at the end that we need to discuss for sure. So the instructions on these are all the same. Find the particular solution. You know the first step is always to separate the variables. What do you think that would look like if we did that here?
dy over y plus 1 is equal to 3x squared dx.
Okay. Take a minute, look at what Anna has said, or what I've written because of what Anna has said. I think she's right on this one. Does that make sense to you all?
Yeah. Just always.
I just didn't want to put any extra pressure, like she's always right. This one, she nailed it. Got it perfect. Okay. Once you've done that separation of variables, what comes next? Antiderivative, yeah. Okay. Oh, and by the way, of course, at this stage, I've earned a whole point, right? Separated the variables. If I do the next stage right, I'm going to get plus 2. What's the antiderivative of that left side? Yay. Nick, you got that one right. Well done. You guys okay with that? It's that left side. Equals what? X cubed plus c. Yep. So at this stage, I've earned 2 more points because I got both of my antiderivatives, one of which involved an ln, which you could debate that that's difficult or not. Often they'll say, hey, that was a little tougher than just a power rule, so you get an extra point there, right? Each individual antiderivative worth a point. Okay, as you guys know, this is where I like to plug in my initial condition. So I'm going to do that. This is where this starts to get interesting. Got to have the absolute values. You guys remember from before, I've been kind of preaching that since the start of chapter 5, and sometimes you guys said, do we really have to have those? And my response typically was, well, you kind of do, but I'll be sort of gracious on if you do or don't at this point. Later on, it's really going to matter. Do you see why it matters now? Because if I didn't have those, wouldn't I get natural log of -1? And I would say, wait a minute, you can't do that. So I'm stuck. But if you remembered that the antiderivative of 1 over y plus 1 is ln of absolute value of y plus 1, you're not stuck. -2 plus 1 is -1. And the absolute value of -1 is 1. And ln of 1 is 0. So we can say 0 equals 1 plus c. Oh, I forgot. I got a point. I plugged in my initial condition with the c in there. So I got a point on that step. And then, of course, this is a pretty easy equation to solve. -1 equals c. Please remember that third step, kind of like third and fourth-ish steps. They're going to come back and be pretty important here in a second. Okay, so here's what I'm going to do. I'm going to go back up here and say this is natural log of y plus 1 equals x cubed minus 1, because I just figured out my c. And now we got to do the solving, and we got to e both sides. So e to the left side, e to the right side. And by the way, sometimes people will make this mistake. When I e both sides, I'm eing both sides, not this. This would be a mistake. Right? I'm taking the whole left side to be the exponent of e and the whole right side, not little parts. Should be this. Okay, let's keep going. The right side, pretty simple. Just e to the x cubed minus 1, all in the exponent right there.
Then you could add or subtract it.
Well, not yet. The reason why not yet is I have not dealt with the absolute values. This will go back to a thing we talked about several days ago. If I asked you a question, hey guys, what's the absolute value of -7? You'd probably look at me like, really? You're asking me that? Like, I did this 5 years ago. I've done it every year since. But if I did say, what's the absolute value of -7, you'd say 7. If I said, what's the absolute value of 9, you'd say. But if I said, what's the absolute value of y plus 1, what would you say?
The absolute value. Same as y.
what's y? Because if y is something like 8, well, 8 plus 1 is 9, and the absolute value of 9 is 9.
Just one.
However, hang on one second. If y is like negative 8, then negative 8 plus 1 is negative 7. And listen, the absolute value of negative 7 is negative 7. Also known as 7, positive 7. So here we go. Let me finish this out, and then I'll get your question. The way that I know how to handle this is based entirely on the initial condition. The initial condition gave us a big hint right here. Did the absolute values have an effect on the initial condition? They did. They took a negative and turned it into a positive, right? They did the opposite of that. And so for me to evaluate the absolute value of y plus 1, I have to realize that for my initial condition, y plus 1 will be negative. Therefore, the absolute value of y plus 1 is this. Does that make sense? If y plus 1 was going to be positive for my initial condition, I do not need that negative out front. But I know that y plus 1 will be a negative, and in order to absolute value that, I need to do the opposite of that negative. Of course, thereby giving you a positive, but I've got to do that first. So my final steps would be this. Y plus 1 equals, I'm just going to divide it over, but you could distribute it if you wanted to. And now I'm going to subtract my 1. So it'd be y equals negative 1 minus e to the x cubed minus 1. So as we talked about last time,
But if you distribute it, wouldn't you get negative y minus 1?
yeah, and then you add 1, but then you'd have to divide by a negative anyways.
Oh, and then you would distribute it.
Yeah.
So gosh.
I mentioned to you guys last time that a lot of the differential equation solutions that we found in the past were kind of like JV. We're going to do some varsity ones. This is a varsity one, right? There are a lot of different angles to this that you got to keep track of. Feels like something we should probably practice more than just the one time, right? So over the next couple of days, we'll get into some more practicing with this. So hope you guys have a wonderful day.
So the test is what through what?
Up through the end of 5.
And this